Hi guys, Mr. Bennett here. Just looking at the main thing that you need to be able to do is apply the sine rule and the cosine rule to applications. Alright, so we're going to look at exercise 1L. So just a recap of what we were talking about before, which is if you're going to use the cosine rule, you generally would use that if you're given three sides or you're giving two sides with the included angle. And then obviously the sine rule, you use that when you get given one side and two angles, or you get given two sides on one of the angles. Okay, so you need to make a decision about which one you're going to use based on the information you get given. So let's have a look at an example for that. So if we go to exercise, we'll just do the first one maybe. So Manny wishes to determine the height of the flagpole. She takes a siding from the flagpole from point P, and then she moves further away from the flagpole by 20 metres to Q and takes a second siding. The information is shown in the diagram alongside. How high is the flagpole? Alright, so that's our diagram that we've got there that we need to use. Now, thinking here, a couple of things. Alright, so we do have a side there. Now, if I want to find the height, I've got a right angle there. If I could find one of the sides in this triangle here, then that would allow me to find height using trigonometry, or if I could find this side here, then that would allow me to do that as well. Right. These questions need you to basically do a little bit of angle stuff. Now that corresponding side there, I would need to know this angle up here. Right. If I know that angle up there, now I actually do know this angle here. Alright, so if that's 53, then this angle here is going to be 180 take 53. So that's going to give me an answer of 127. So that angle there is 127. Alright, if that's 127 plus 28, so that's going to give me 155. So therefore this side over here is going to be 25 degrees. Alright, that angle there. Alright, so that's important that you can identify some things. And now I have a corresponding side and a angle, and then I could use this angle and the corresponding side. So I could actually find x. Alright, so let's maybe for some of these is to draw the diagram that we do have. So let's draw this triangle here. Right, so we know this angle up here is 25, that one there is 28, we know this side here is 20 metres, and I want to find x. Alright, so I'm going to do that, I'm going to use the sine rule. So x to sine 28 is equal to 20 metres to sine of 25. We're expecting the side to be a bit longer than 20, aren't we? So x, now you have to just bring that up to the top line, equals 20 sine 28 all over sine 25. So then you can just do that in the calculator. So I'll just clear that. So 20 sine 28 divided by, I should put a bracket there, divide that by sine of 25 and enter. That gives me 22.22. Okay, so go back to our thing. So x is equal to 22.22 metres. Now the second diagram that we've got here is this one here. This is a right angle. You know this side over here is 22.22 metres. And this angle in the bottom there, if I remember what, that's 53. Okay, so that's 53 degrees. And just doing the next part of that, so if we think about this side here, we want to find the height. So therefore that there is the opposite side, and this is the hypotenuse. So then I can simply use sine to do that. So I can go sine of 53 degrees equals opposite, which is h all over 22.22. So therefore h is equal to 22.22 sine 53 degrees. So go to your calculator. And do that, so it's 22.22 sine, 53 degrees, and you've got your answer of 17.75. Okay, so that's my answer there, 17.775 metres. Right, if I was looking at question number two is related to a lake, and what you're doing is you're going to go from P to R, the park rangers to walk along a path to Q, and then R is shown. What would be the distance if he could walk in a straight line from R to Q? Alright, so quite clearly you've been given two sides there, and the angle between those two sides is 112 degrees. Alright, so it's always good practice to draw a diagram of it. Alright, so even if it's quite obvious there, obviously in a test I'll give you that diagram drawn so you can just go straight to it. So that's 112 degrees. Right, coming to the next bit over there, 175 metres and 63 metres. Yep. And hopefully you've identified that the angle between two sides is quite clearly going to be cosine. And so I'm trying to find this x from P to R. Okay? So therefore, what I'm going to be doing is I'm going to say x is equal to, using the cosine rule, bit of a wobbly line there, doesn't matter which way you do it, 63 squared plus 175 squared, take two lots of 63 times 175, cosine of the angle between the two. So calculate a jobby, just do it on one step, makes it easy, don't have to any rounding off errors. 63 squared plus 175 squared, take 2 times 63 times 175, cosine of 112. Enter, gives me a distance of 207.01 metres. I'll just say it's 207 metres. It's probably easier. The others are in whole numbers, so it probably makes sense to give that in whole numbers. I've lost my page. Okay, so I can't write that down for some reason, but you know the answer is 207 metres, and that's it. Alright, so that one there is using the cosine rule, the other one was using the sine rule. So it's really important that you draw your diagram, label your diagram that you actually want to use to solve your problem first up, and then go through. Sometimes you'll have to do more than one diagram to actually get your final answer.